Welcome to Meeting SPI. The Serial Peripheral Interface Bus is a synchronous serial communication interface widely used in embedded systems. SPI devices communicate in full duplex mode using a master-slave architecture, with a single master using only 3 wires and an additional one for each slave device. In the next demo, we will use an SPI peripheral of the microcontroller to drive one or more shift register. In this case, master is our STM32F4 and slave device is the shift register. As first step, we had built this simple circuit. As said, only few connections are needed. Remember that you can find schematics and more details on plainbedded.org under the section ChibiOS RT tutorials. In our code, let's create 2 threads. One managing SPI communication, the other managing data that first one had to send. Remember that every driver, except PAL, must be started before using. So before thread loop starts, we made a SPI start, configuring the SPI properly. Note that SPI config depends strictly from hardware resources, and it's different from MCUs to MCUs. In thread loop, we had just to send out a word. The second thread is quite simple, just increasing the word TX and updating the sending word. As its name suggests, not TX is one's complement of TX. We send out a complement because our circuit works in negate logic. That means that sending a logical 1, we are actually shutting down a LED. In our main loop that actually is another thread, we could print on serial the TX value. Let's look how circuit works at that point. Shift register could be connected as cascade, so in the next step we would just modify code in order to send out 2 words instead of 1. Now MCU is addressing 16 LEDs using only 5 wires, 3 of which are actually used by SPI and the other are supply. Of course, another application could be that. You could download the 3 projects on plainbedded.org.